All right, this is the last lesson in Unit 4. It's applications. It says goals. I can find the measure of angle pairs given algebraic expressions, and I can determine if a pair of lines are parallel based on the measures of angle pairs. Okay, let's take a look here. So the first set of application questions deal with a pair of parallel lines. So we already know they're parallel. So right here we know those are parallel. And so we're just coming up with, we're solving to figure out the measures of angle 4 and angle 7, for example. Well, we know angle 7 is 85. And we can quickly figure out angle 4 if we wanted to. Are they equal or do they make 180? I guess that's the question we have to ask ourselves. With lines parallel like that, the angle pairs we choose over here are either going to be equal to each other, they add up to 180. Well, it looks like 4 is an interior angle and 7's an exterior, and so they're not one of our angle pair names, but we can see angle 4 is congruent to angle 5 because they're alternate interior, and then 5 and 7 are linear pairs, so they would make 180. So my equation needs to look like this: 2x minus 17 plus 85 equals 180. Ugh, the 5's on this thing. They always tail on. So equal 180. So small plus small equals large, right? So I'm adding two angles together to make 180, and I'm solving that equation. So I'm going to combine my negative 17 and my 85. So 85 minus 17, because they're like terms, that's 68. So I have 2x plus 68 equals 180. I'm going to subtract 68 from 180. And so I get 2x equals 112. And then I divide by 2. And I'm going to get 56. So that means the x value is 56, but that's not the measure of angle 4 yet. Measure of angle 4 then is 2 times 56 minus 17. And that's 95. Now, couldn't we have just taken 85 and subtracted from 180 and gotten 95? I think that would have been a little easier, right? But the point being, you're going to need to set up an equation for a lot of these. Like go to the next one. We don't know either angle. But we know we're talking about angle 3 and angle 5, and they are both interior, and they are consecutive, meaning on the same side. So we know the rule for that is they are supplementary. So I'm going to add them together and set them equal to 180. So 4y and 7y make 11y. 31 and 6 make 37 equals 180. And I'm going to subtract 37 from 180. And I get 11y equals 143 divided by 11 means y equals 13. So let's do angle 3. 4 times 13 plus 31. So 4 times 13 plus 31 is 83 degrees. So angle 3 is 83 degrees. And subtract that from 180, and we get 97 for angle 5. So angle 3 is 83, and the measure of angle 5 is 97. Okay? You try the next one down there. So what's the relationship between 2 and 7? Well, they are both exterior and they are alternating, which tells me they have to be equal. So I'm going to say 4x plus 7 equals 5x minus 13. I'm going to subtract 4x from 5x and get x. I'm going to add 13 to 7 and get 20. And then I'm going to figure out, I'll do angle 7 here. So angle 7 is going to be 5 times 20 minus 13. So that's 100 minus 13, which is 87 degrees. So they're both 87. Okay? Because they're equal. 3 and 6. 80, 180, or equal? Well, they're both interior, and they are on opposite sides of the transversal, so they are alternating. So that means they are equal. 2x minus 7 equals x plus 43. If I subtract x from 2x, that leaves me x, and then I'm going to add 7 to 43. That makes 50. So x is 50, and then right here, I can say 50 plus 43 equals 93 for both angles. Okay? So that's if the lines are parallel. We know the relationship. Okay? Now, if any of those relationships are true, corresponding angles congruent, alternate interior angles congruent, alternate exterior angles congruent, or consecutive interior angles are supplementary, then we can prove the lines are parallel. So what's different about this slide is now we're going to show that if the corresponding angles are congruent, then the lines are parallel. Instead of saying, okay, I know I've got parallel lines, therefore I know the angles are congruent. It's the opposite. We're doing the converse of that statement. So now we're saying if we get corresponding angles, then the lines must be parallel. Okay? So we're going to talk about those things. We're going to come up with values that will make the lines parallel because they'll make one of these things true. The other thing you need to understand is if two lines are perpendicular to the same line, then they're parallel. Okay? They're just corresponding angles or right angles. And so they're going to be perpendicular. They're parallel to each other. Okay? So we'll look at that as well. So given the information over here, the bulleted information about the angle pairs, identify any parallel lines and justify your answer. So they're telling me angle 2 is congruent to angle 6. Well, what kind of angle pair are those? Well, they are corresponding. So for these two intersections, angle 2 is the upper left-hand angle and angle 6 is the upper left-hand angle, so they are corresponding. That makes M our transversal, and therefore P is parallel to Q, and the reason is the corresponding angles are congruent. Okay? Next pair, 4 and 3. So 4 is congruent to 3. Do they share a transversal? Like, is there one line? Does the same line go past both angles? Does the same line form those two angles? No. So this is none. How about 8 and 2? 8 and 2, they have a transversal, which is M. And so the two parallel lines are going to be P and Q. Well, what kind of angle pair are 8 and 2? They are exterior. They're on the outsides of P and Q, and they are alternating across M. That makes them alternate exteriors. And so, again, line P is going to be parallel to line Q because alternate interior angles are congruent. All right. 5 and 3 are, they are interior between M and N, and they're on the same side of our transversal. The transversal is P, and M and N now are the parallel pair lines. And the reason is, what kind of pair are those? Consecutive interiors are supplementary. That's our reason. Okay, that's an N. It's a good one. Okay, how about 1 and 5? Well, 1 and 5 are both interior, the between M and N, so P is their transversal. So M and N are the parallel pair of lines, and 1 and 5 are alternate interior angles, and they are congruent. So that's how those work. So look at the angle pair, figure out the transversal. The other two lines are potentially parallel if you have one of the angle pairs congruent or supplementary. Okay? So here's a proof of that. All right. So if two lines are cut by a transversal so that alternate interior angles are congruent. Well, let's make a pair of alternate interior angles congruent here. Angle 1 and angle 2. So we're going to say that that's what we have. We have angle 1 congruent to angle 2, and that was given to us in this statement right here. Okay. We need to prove the lines are parallel, M and N. Well, our postulate is the corresponding angle, so I'm going to say angle 3 here. Angle 2 is congruent to angle 3 because vertical angles are congruent. And then I can say angle 1 is congruent to angle 3 by transitive. And then I can say M's parallel to N by the corresponding angle postulate that we studied a couple sections ago. Okay? That's building. So this, I don't know what happened to this slide. So we're just going to make up a pair of numbers. It says find the value of x that will make M parallel to N. Well, if I call this 10, let's not do that. Let's call this 8x, and I'll call this 10x. Okay, so it says find the value of x that will make M parallel to N. What kind of angle pair are 8x and 10x? Well, they are interior, and they are on the same side of the transversal, so they are consecutive interior. So if I find the value of x that makes them supplementary, then the lines will be parallel. So I'm going to say, all right, I need these to add up to be 180. So 10x and 8x make 18x. I can divide by 18, and I get 10. Well, that means the angle measures have to be 8x, 8 times x is 80, and 10 times 10 is 100. And so if my angle pairs are 80 and 100, those are supplementary, and my lines will be parallel. That will make them parallel lines because that relationship is 180 between those. Okay? Find the value of x that will make M parallel to N. Well, name that angle pair. Well, they are interior, they are alternating, and in order for M to be parallel to N, they would have to be equal to each other. So 3x, not plus, minus 43 would have to equal 2x plus 7. So I'll subtract 2x from 3x, and I'll add 43 to 7. And so what's the value of x? 50 is the value of x. I could figure out the angles too. 2 times 50 is 100 plus 7. If these are each 107, so 3 times 50 is 150 minus 43 is 107. Yeah, so if they're each 107, then M's going to be parallel to N. Find the value of x and y that will make M parallel. This one disappeared on me too. So let's call this angle 5x plus 10, and we'll call this 9x minus 40. Let's see what happens there. Well, what would have to be true about that pair? Well, they're corresponding, so they would have to be equal. So let's say that when 9x minus 40 is equal to 5x plus 10, we'd have a pair of angles that were equal. So subtract 5x from 9x, add 40 to 10, and divide by 4, and you get 12 and a half. So if x is 12 and a half, there's no y. If x is 12 and a half, then we've got parallel lines there, M and N. Okay. Here's a good one for you. What kind of angle pair are those? This is alternate exterior. They're on opposite sides of the transversal, and they're outside or exterior. This is interior, right? So they would have to be equal. So I'd have to have x squared equal to 5x minus 24. And so this little test of your memory skills on solving quadratic because you got an x squared. So the rule is move everything to one side. So subtract 5x, add 24, equals 0, and try to factor. What can you multiply to get 24? 1, 24, 2 times 12, 3 times 8, 4 times 6. I think that's it. Is there a pair there that add or subtract to 5? Yes, 3 and 8. And to get a negative 5x in the middle, I have to have a negative 8 and a positive 3. The solution here would be negative 3, and the solution here would be positive 8. Well, if I plug negative 3 in, 15, I think that would work still. I think they're both good answers. So if you plug in negative 3, you're going to get negative 15 plus 24, which is 9. So either 9 degrees, and then x3 squared would also be 9. If you plug in 8, you're going to get 40 plus 24, or 64. And then 8 squared, 64. So yeah, they both work. Both give me valid answers. 64 and 9 degrees. One of the two. Okay? All right, you won't have anything like that on your own, but there's some application practice, a form, if you'll find that and fill that out.